Today, I'm going to talk about the next set of Sparkfun Inventor Kit circuits. So I broke this down into 7 through 11. They're listed here on the module on the SIK circuit 7 through 11 page in Canvas. And I'm gonna kind of start at the top. I'm gonna do number 7 and we'll see, maybe I'll do 1 or 2, see how we go. I'm gonna do these in TinkerCAD Circuit Simulator. As I did before, just going to kind of walk through what you should be learning from doing these example circuits. So I'm going to start with number 7, which is reading a temperature sensor. I'm going to click on the link. It will take me to the Sparkfun page for version 3.2. This is the kit you were using in class, so this is what we're sticking with for now. It has a little introduction for what this module is supposed to show you, the parts that we will need, which are the breadboard, the Arduino Uno, jumper wires, and a temperature sensor. If we go down a little ways, it's got how to hook up one of these. So this temperature sensor has a ground wire, a power or voltage wire, and a signal. And if we scroll down a little bit more, we'll be able to see exactly how to hook it up. So here is the wiring diagram. These are the same, you can look at either one. If you need it a little bit bigger, you can click on it. Basically, we will have power and ground going out to a rail. We'll have the temperature sensor going to power and ground, and then we will have the middle wire that goes over to analog 0. If you scroll down a little bit more, this is the example code that we will run. It has a little bit in here on code that you may not have seen before that you want to go learn about, and an example of what we should see. So let's give this a try. I'm going to go over to my TinkerCAD circuits. I'm going to go rename this SIK version 3.2 temperature sensor. Here we go. So the first thing I'm going to need is a Arduino, and I know I want the one with the breadboard, so I'm just going to bring that guy out. Now I need some components. So the most important thing, I think the only thing I really need right now, is a temperature sensor, and there it is. It says TMP on the front. You can put it kind of wherever. I'm going to put it somewhere. I like putting them kind of at the top of the rail so I have all of this space in which to connect wires. If you hover over the end points, it's really nice because they tell you what part should be connected where. So G and D, that's ground. I'm going to take that to ground. I like to keep my color coding consistent, especially for these videos. So power is going to be red. Ground is going to be black. However, it doesn't make any difference. You can make them whatever color you want. This middle one, if I remember correctly, refer back, yep, is the one that's going to A0, analog 0. So I don't usually connect those right there either. I like them to be down a little bit. There we go. Okay. So one of those middle path ones, and it's going to come down to A0. There we are. Green is fine. Okay, so this should be wired up correctly now. I'm going to go back to the guide and go get the example code. Now if I open up this code section, remember we're going to switch to text. I'm going to replace what's here by select all and then deleting it, and then paste in the code from the Sparkfun page. All right, so before we hit run, let's see if we can figure out a little bit of what is supposed to happen. So if we look right up at the top in their header section, it's which example we're working on, the fact that we're using a temperature sensor, and they are telling us we are going to use the serial monitor to read the temperature. So if you haven't used the serial monitor before, now is the time. We're going to learn how. This has be careful how to install the temperature sensor, and they do have very, very tiny letters in the real world, and they look exactly like the transistors that come in the kit. So we want the one that says TMP for temperature, not the one that says 222. But fortunately for us, in the simulator version, it's a lot easier to tell which one's which. Okay, so let's go down. Similar to our other programs, we're going to start by telling it which pins we're going to use for which devices. So this time we only have one sensor for now, and it is plugged into analog 0. So that's what this guy is for. In our setup section, it might be a good habit to set up the pin mode for A0, but since these are always ready to accept analog input, we should be just fine. Here is the important one, serial begin 9600. So the serial monitor, which is right down here, we'll click on it in just a minute. You need to tell the program that you would like to use it. So that's what the serial.begin means. And 9600 is the baud rate. It's explained right up here. It's the communication rate between the board and the computer. This matters a lot more when you're using a real live Arduino on a real live computer, but this is the default for Arduino Unos, is the serial.begin 9600. All right, we're down into the loop section, which is the actual program part, right? Okay, so we are gonna set up some variables, voltage, degrees Celsius, and degrees Fahrenheit. And then we are going to calculate them. So what's actually going to happen is all we're reading from this temperature sensor is voltage. Okay, so it's going to get voltage from the temperature pin. If you wonder what get voltage is, if we scroll down a little bit, here is the name of that function. So this function is going to analog read the pin A0 and multiply it by this kind of conversion factor. And there's an explanation of exactly how they come up with that number, I believe, on their website. But most importantly, this is, yeah, right here. So this is returning the 0 to 1023 value that we get from an analog read and turning it into the 0 to 5 volts value that is what we actually need for this calculation. And that's really all this particular function does. So if we go back up to where we were using it from, there we go. This is where we were using that voltage reading right here. If we go down just a little bit, we're now going to use that voltage reading to calculate degrees Celsius and degrees Fahrenheit. And it does that just through this kind of basic math problem, right? How it converts that exactly, you could look up, and I think it might even be linked on this page, how you calculate in between Celsius and Fahrenheit, but that's all that's happening right here. If we go down a little bit more, we get to our serial print section. So what this does is, and we'll see it in just a moment, it sets up some print lines in order to share the value back with us. One of the things that can be hard to kind of wrap your mind around with Arduinos and electronics in general is we know that there's stuff going on in there, but it's hard to read exactly what's happening. And so the serial monitor is the most default and important way to get the Arduino to tell you what it sees. So we are going to get a printout of exactly what's going on this temperature sensor. And then we're going to wait 1 second and then start over. So that's the whole program for this one. Take a reading, calculate Celsius and Fahrenheit, print it on the screen. That's it. So let's give it a shot. We're going to hit Start Simulation, Okay, so we can see that it's running up here, but it doesn't look very exciting right now. There's no moving parts on this one. We need to go down to serial monitor here at the bottom of the screen and click that. And we can see now that it is reading the voltage at 0.75 volts. And it's coming up with a degree measurement of 24.71 and a degree Fahrenheit measurement of 76.47. If we click on this temperature sensor, you can see that, like the other sensors in the simulator, we can kind of simulate what it might be experiencing. So I believe if I go this way, it's going to get colder. And you can see in the serial monitor what happens. So the voltage reading went down to 0.32, which means, oh, it's very cold in my fake room now. It's negative 18 degrees Celsius, and it is just below 0 degrees Fahrenheit. Very cold. Hopefully a classroom never gets that cold. And if we go slide to the other direction, ooh, I wouldn't want to be in this classroom either. Okay, so voltage of 1.49 means a degree Celsius of 98 and a degree Fahrenheit of 210. There's definitely something going wrong if our classroom gets up to that temperature. All right, somewhere in the middle. There you go, closer to where we started. So that's all that this particular program does. It's reading this sensor, performing some calculations, printing it out on the screen. If we go back and look at our guide in Canvas on what we are maybe supposed to learn, what lines of code display the temperature? What lines are necessary to establish communication between the sensor and the computer? So for us, the establishing communications, that's this guy right here, serial.begin. And what is it printing out? It is printing out using these particular lines. So what could we add? Let's add something. What do I want to add? I'm going to add right here a if statement. If degrees Fahrenheit is greater than, let's think, I am a person that likes a pretty moderate temperature. I'm really happy in that like low 70s place. Really, if my classroom starts getting over like 80, I'm not super excited anymore. So I'm going to say if degrees Fahrenheit is greater than 80, we are going to serial.print ln, and I'll tell you why the ln is on there in just a second. It's too hot. Okay, so this line says I'm going to look at the variable degrees Fahrenheit. I'm going to see if it's greater than 80, as it is right now. If it is, I'm going to print out it's too hot. So why print ln versus regular print? So if you look back up here, this serial.print voltage, that's this first part of the line. Oop. Kind of this first section. Serial print voltage, that's this measurement. Serial print degrees Celsius, that's this center section. Serial print degrees C, that's this section. Serial print DGF, that's this section. And serial print degrees F, that's this at the end. So because these lines were all print statements, they all appear on the same line. It kind of lines things up one after the other. It's only when you get to this very last one, serial.println degrees F, so that prints the degrees F variable and then starts a new line, so that when it comes back to this voltage, that will show up on a new line instead of just kind of scrolling forever. And so I want mine to also appear on its own line and show up on its own section, and then hit return so that the next part can be on its own line as well. So I'm going to go ahead and start the simulation. Okay, and by default, this starts at 0.75 volts, and so it's below that 80-degree threshold right now. So if I turn it up a little bit, there you go. It's too hot. It's too hot. And drop back down, and oh, okay, now it's not too hot anymore. Good. Could I also use that to maybe turn on a light, that a red light for when it's too hot and a blue light for when it's too cold? Absolutely, that would be a really good extension to do right here. And if I was going to do anything like that, I would need to remember to identify the pins I was adding it to, add it to the setup section before I try and actually use it. All right, so that was example 7, reading a temperature sensor. I guess let's go take a look at the next one, the servo.